The next speaker literally needs no introduction. Again, I keep talking about losing count. The other thing I've lost count of is how many times has SACHIN presented to Data Science Sydney. And we're glad every time, because he is, as you will see, and as many of you have come here specifically to see, he has tremendous value. And well, I don't really need to read SACHIN's profile, because I probably know it off by heart. I mean, you know, yes, PhD, but doesn't everybody? Actually, more to the point, if I ever get lost with Bayesian statistics, and trust me, I get lost easily with Bayesian statistics, he's someone to ask, because his PhD is in Bayesian statistics, and as those of you who spend a lot of time around PhDs might know, there's having a PhD, and then there's actually understanding stuff. He actually understands the stuff, but he still uses his Bayesian knowledge to great effect, but he had discovered a new love, and his new love was the latest developments in neural networks, what might be colloquially called deep learning. And he took that to some tremendous lengths, and indeed developed a very well-regarded and massively followed, I think in the hundreds of thousands or millions, is it?
Thousands.
In the thousands.
Yeah,
well, pretty big. I thought there was something that was up there. Maybe the number of visits was in the millions.
Visit was millions.
So very, very well visited. Deepschool.io.
Yeah, that's right.
Deepschool.io, which is his own set of guided code training videos in the various deep learning tools in Python. So I actually promised him I remembered how to pronounce his last name. ABEYWARDANA.
Yeah, that'll do.
So, Dr. SACHIN ABEYWARDANA, take it away.
Thank you. Okay.
SACHIN Ananda ABEYWARDANA.
Sachin Thakur, but yeah, that's close enough. Okay. Okay, all right, let's start with that. All right, so just a quick introduction to who I am. So I have presented here quite a few times, so hello again. So I did do my PhD in Bayesian machine learning, and now I'm currently a senior machine learning engineer at Canva. And I try to make everything about deep learning these days. So what do I mean by that? So mainly the fact that from what I discovered, everything that I've done in machine learning is one way or another related to gradient descent. So if you're doing gradient descent, you can write that in deep learning these days, right? So so when I go through this talk, so the talk today is going to be about a package called ProFeTorch, which is, by the way, I might as well get a hand count. Who here has played around with Prophet? Yeah, it doesn't matter if it's Python or R. Yeah. So if you haven't played around with Prophet, it's a time series package, a general time series package, so that you can just go. It's almost like the scikit-learn of time series problems, right? So what I went ahead and did is that I decomposed the tiny modules that was in Prophet and rewrote everything in PyTorch. Now, why did I do that? There was a few reasons. One, I like deep learning. Two, I wanted to make things faster. So especially if you're dealing with larger time series problems, I wanted to be able to program with GPUs. So in today's talk, I'm going to be talking about two other things. So fast AI and NBDev. Fast AI is it's a wrapper. It's more or less a wrapper to do deep learning in a very faster way. Okay. And by the way, feel free to ask questions during the talk. I don't mind. In fact, I encourage you to do so because it's going to be a very short talk otherwise. No. Yeah. So why create ProFeTorch? So there's a few limitations in face with Prophet that I didn't quite like. The biggest problem that it had was that it allowed you to say, I want the boundaries. I wanted my time series to be between, in this case, 0 and 50. It didn't really adhere to that, right? So it would try its best to stick within those limits, but it would easily go below or under depending on which way the time series was structured. But just as a quick motivation, actually, so stepping a few back, the reason that we came around to this problem was we were dealing with some sales problems at my last company. So we were trying to predict the number of sales, forecasting them. But the problem with Profit was that it was predicting negative sales. So obviously there's a limit of 0 as a boundary below. You can't go below that. And Profit, no matter what you did, take out the outliers, to take the log transform, for example, it just did not accept 0 to be the lower boundary, even though I specifically said 0 should be the minimum boundary. So that was the first thing that I set out to fix. The second thing, like I mentioned before, try and use GPUs if possible. Sometimes it doesn't make sense to use GPUs. You don't need to. And the last thing, quantile regression. Has anyone here played around with quantile regression? Okay, so just a quick introduction to quantile regression. So with most regression problems, what you try and care about is the average prediction, right? And with quantiles, what you're trying to predict is the boundaries, right? So you can go the 5th percentile, 95th percentile. The most naive way that you can do this is to go, if I have this kind of large amount of data, I can just go, I'll take the 95th percentile of each time slice and try and predict on those ones. So that's the most naive way. But there's a bit more rigorous way, which is tilted loss function. So again, it's about changing the loss function, and you can get the quantiles, which I'll talk about in a bit. Any questions so far? No? All right. All right, so the quantile regression, the loss function. Yeah, so this is what the loss function looks like, right? Now, if I take the 50th percentile, which is the median, the loss function is this orange line over here. So you'll actually know this. Most of you will know this because it's simply mean absolute average. Okay, so most of the time you care about mean squared error, but in this case it's mean absolute error, right? So people were obsessed about mean squared error because you have nice properties with differentiation, right? So whereas in this case there's a problem at this end or there because it's a nice sharp edge. You don't know what the differential is, right? So you can't set. It's not a simple matter of setting your gradient equal to 0, right? So that's why mean absolute error wasn't as popular as mean squared error. But it turns out if you tilt it to a particular angle, you can get the other quantiles as well. Okay. Now, a problem of doing quantile regression generally is that when you do the quantile regression, you don't care about the other quantiles. So for example, if I do the 50th percentile and the 95th percentile, you do the regression separately. And then it can turn out that the regressions cross each other. Right? Now that doesn't make sense. Right? In ProFeTorch, I did a little trick, which I will go through later, which forces it to not be able to cross. Right? The reason that it usually crosses is because you are doing the regressions independently. Right? The one regression problem doesn't know about the other one. So it is possible for those lines to cross. But in this case, I specifically said you can't do them because I do all 3 regressions at the same time. Okay. Right. PyTorch. Now, if you play around with NumPy, you already probably know most of the PyTorch syntax. Right? It's just a matter of just going torch dot instead of NumPy dot. Okay. Gradients are free to take. Right, and that's true of every single thing. Doesn't matter if it's TensorFlow or PyTorch. And it's also easy to write. So I'll just quickly show you what the loss function look like. So it's just a simple matter of 2 lines. So I go the error is y minus y predicted, and then the clamping. So it clamps below by 0, clamps the negative thing by 0. Okay, so there really isn't much more to it. Right, so that is the tilted loss function I just talked about 2 slides ago. All right, let's keep going. Yeah, and the fact that it's Pythonic. So if you're into Python, PyTorch will make a lot of sense. Okay, NBDev. Who here develops Python code? It doesn't matter if it's for machine learning or if it's, yeah. So out of those people, if you develop packages, who here hates notebooks? Okay. So I love notebooks, right? And for a long time, for you to be able to develop a package and for you to be able to write in notebooks were well, not completely, but they weren't really overlapping things, right? So the fast AI guys released this thing called MBDev, which means you can do both. So I'll just show you actually, I'll show you as a demonstration as we go along. But the good thing about MBDev is that you can test your code. It speeds up your coding because you can autofill. Anyway, so there's a few other advantages as well. Right, so let me talk about the components of ProFeTorch. It's simply a matter of let me go to my documentation. Right. So so there's 4 components into this: the trend line, the seasonal line, and f of x. Well, f of x in this case is just linear, right? So these are and the boundary. So B is for boundary. So those are the 4 main components of ProFeTorch. Now, you will get the first 2 components in Profit, but you won't get the other 2 components in Profit. This other linear function and the bounding thing. It tries to do the bounding thing, but not too well. So let me show you what I'm talking about. Right. So this is NBDev. Well, it's still a notebook, but it's really the special markers that I put in that really changes things. So let me zoom out so you can see more of it. Now, so what I'm saying over here is that I want to export this Jupyter Notebooks into my blocks folder and call it Fourier.py. Okay, so that's the first thing that I do. That's not too important. So what I'm doing over here is I'm creating dummy data. So in this case, it's a Fourier series that I'm creating. And sorry to show you a bit of maths, but that's what a Fourier series is, right? So you've got a bunch of coefficients of causes and sines that you add up. And just to show you what the Fourier series will look like, so in this case, I have a yearly trend and a monthly trend. Okay, so add those 2 up, I end up with my final time series. All right. So one thing that I really want you to notice is the fact that this yearly component during this 365 days isn't just a simple sine wave. Okay, so it's a combination of 3 ways. You can get much more rigid lines if you add more and more Fourier components, but essentially that's the idea, right? So the task that we're trying to do is we're trying to find. So if these are the actual Fourier components, I'm going to try and find those components. Okay, so that's the actual data, and what I do is I create this Fourier module, and all I'm doing is I have a bunch of causes and sines, and then I have a linear layer over it. Okay, any questions about this particular thing? So these 3 lines is exactly the same as me doing this thing over here. Okay, it really is no different. Yeah, but you had to say what's the maximum number of Fourier components that I want. In this case, 7. The scale is if I want to shrink or expand the time, and P is a period. So in this case, 365.25 because of leap years. Okay. And there's another module called seasonal, and all I do is take yearly, monthly, and weekly, sum them all up together. The only difference between these 3 is the period. Okay, so the period is 365, 30, and 7. Okay, so all I'm doing is adding those up. So this is the testing code. This is a tiny part where fast AI comes into play. All right, so I specify what my model is. In this case, Fourier model. You have this concept called learner where you had to put the data, the model, and the loss function all in one place. right? But one of the cool things that FastAI does is learning rate finder. Now, all the deep learning talks that I've given, everyone asks me, why did you choose this many layers? How did you choose the learning rate? Now, most of the time I don't have an answer, but at least for learning rate, now we can start to give an answer because what they do is you try and find the loss at each learning rate, right? So you go from 10 to negative 6 all the way to 10, you change it, and then you try and find where the steepest gradient is. So in this case, the learning rate is going to be 2e neg 1, right? So just so just in interest of time, I'm just going to skip over this. So the fit.1 cycle is almost the same as .fit, except the learning rate is changing. All right, so 10 to the negative 1 is actually the maximum learning rate you can go to. Yeah, so I fit it, I end up with this thing. Yeah.
How long does this take to figure out the learning rate?
How long to figure out the learning rate?
Yeah, when you run that. Is it quick or is it?
30 seconds at most. Yeah. But again, you don't have to do that, right? So I could have easily skipped that step and just put in something random over there. Right? And I'll actually talk about the learning rate at the end, because it is one of those things I feel like in this case I didn't need to have, because it was a linear thing, and I could have just taken the learning rate of 1 or very close to 1. Yeah. Any other questions? Yeah.
Fourier transforms and the Wavelet transforms is supposed to both convert to the frequency domain from the time domain.
What Fourier transform and
Fourier and Wavelet.
Wavelet, right? Yeah.
So any reason why you picked Fourier over the Wavelet?
Only because I want to be similar to ProFet, but absolutely you can choose the Wavelet transform as well. The only thing that you need to do is go back and write this module. So instead of Fourier, like instead of causes and sines, whatever the base functions are. Okay. Yeah. Any other questions? Yeah.
So just to clarify, you're effectively getting the Fourier coefficients by fitting rather than doing a discrete Fourier transform.
That's right. Yeah. So I'm not doing the Fourier decomposition to get this one.
Right.
Yeah. And I'll talk about why as well. So yeah, let me go to the next ones, and then I'll come back to that, to why I don't just do the decomposition. Yeah, so in this case, the reason why it's smoothing it out is because I chose the period to be 365, but if I chose a seasonal thing instead, which has yearly, monthly, and weekly, the weekly bit I actually set to 0, in that case, I get that kind of fit. All right, so obviously it isn't great, because like after the testing point, it's not fitting too well. For the training set, it is fitting better, obviously, but yeah. Okay, so that's the first component of ProFeTorch, or ProFet, I should say. The second is trend. So trend looks like this. Right, so the green line is what trend looks like. Right? So it's a broken trend line, but it's a continuous broken trend line. And what I'm trying to do in this case is try and fit to this data, which looks like this in this particular case. But anyway, just to go through the code quickly, it's more or less y equals mx plus b, but the subsequent one, you change the gradient a tiny bit. Right? So that's the basic idea of this one. It's too much code for me to go through there, so I'm going to skip this one. The third component is squasher. So squashing is the one that is going to make sure it fits between boundaries. So in this case, if that was the data that was going through, it's going to squash it to be between those boundaries. All right. There's a tiny tweak where I say I actually want the gradient to be the gradient of that line to be 0.001, mostly because of gradient descent. Okay. So if the gradient is 0, you find that the information that flows back through the weights is nothing, because it's a flat line, which is a problem of deep learning. But yeah, so that's that. And then the final component is linear X. So ProFet, unfortunately, can only deal with time series things, so it can't take in anything that's not time series. So in this Yeah, so any non-time related data, you send it as a data frame in this package, and it'll just put a linear layer on top of that. Okay. So just finally, the final module is going to be, I'm going to add up my seasonal, my trend, and the linear component. So when I say linear, I'm talking about the linear X component, and then I'm going to squash the predictions. And that's it. And that's it with the, in terms of what is happening under the hood. All right. I do a bit more to get the quantiles. So I talked about non-crossing quantiles before, and the trick that I do, the way to do that is I take the median, and then I add a positive number. Okay, so basically, if I take the exponential of any number, it's always positive, right? So a soft plus is almost like the exponential, but yeah, it makes all the numbers positive. And that's really the trick to make sure that none of the other quantiles cross each other. All right, I'm always adding on. So median plus something, median minus something to get the bottom and the top quantiles. Yeah, so, oh yeah, and coming back to the question about why I don't take the Fourier decomposition, it's because I have all these other components to deal with as well. Right, so if I just do the Fourier thing, it'll just try and fit only the Fourier components, which is not what I'm after, right? Okay, live demo. I'm hoping this works. And by the way, all of this is becoming part of the documentation. So everything that I'm writing here, if you go to my, well, actually this link is on the meetup page. If you go to this link, everything that I've written over here, so for example, the squasher, it's, yeah, all of that is over there. All of that is becoming documentation, thanks to NBDev. All right, so let's run this. And okay. And by the way, it's live now, so if you want to play around with it, please go pip install ProFeTorch. You should be able to play around with it. So it's getting this data set from Profit, and that's what the data set looks like. So I've split it into training and testing, and if you notice, I say hide over here, right? So hide means it's not going to show up in the documentation. If I had a hash export, it'll export it to my .py file. So in this case, what I want is 10 Fourier components for the yearly, 7 Fourier components for the monthly. For weekly, by default, is 0. So for the lower bound, it's going to be 0, and the highest that I want to do is twice the max. Right, so I do that. So you can see it training now. So it's training for 30 epochs. So an epoch is a run through a single training data frame. So in this case, the batch size and the size of the training data frame is exactly the same, right? Actually, let me run that again because I went a bit too quickly. But one thing you should look at is that the validation loss is most of the time going down, which is not always true. Yeah, so one other thing which I haven't implemented is that I can implement early stopping, right? Because I do have the validation set, and yeah, if the validation loss starts going up, I can make sure it stops so that I don't overfit. And once I do the predictions, so it's not a great fit, as you can see on the testing set, it's not fitting at all. But the reason that so with Profit, it does fit, and the reason that it does that, and I haven't implemented yet, is that the trend line is broken. But in this case, I've set the trend line to be a single parameter, right? So it's just a straight line. And if I want to see the components, so what I mean by components is the monthly and the yearly cycles. This is what it looks like. Now, if you look at this, you can see that there's things repeating even in the yearly cycle, right? And the reason, well, my hypothesis as to why it's happening is because I took 10 components, and that means that the yearly period is going to get divided up until 365 divided by 10, which is almost monthly, right? So it's picking up some of the monthly components in here as well. Okay. But yeah, so again, with monthly, I've taken too many components there, so I need to reduce that. Yeah, so that was just showing the model parameters. Anyway, so that was pretty much all I think I had to talk about. Yeah, so that's all I had to talk about in regards to ProFeTorch. But in terms of basic usage, all you had to do is import the model, specify the number of epochs, and alpha in this case is a weight decay parameter. You don't have to have it. It's I think it's that number by default, and then you just go model.fit and model.predict, right? So it has to have two. So for this trained data frame, it has to have two fields called ds and y. Any other column that's given in there will be treated as a numerical column, right? Which means that will form part of the linear x part, right? So that's actually one advantage over Prophet. So Prophet can't deal with anything that's non-time series related. So you can have holidays, you can have special days if you want to, but it can't say something like, or today's a promotion. So you can't have a binary going 1 0 1 0. So and that's really useful for sales kind of situation. Yeah. So clearly there's a bit to improve, right? So when I showed you that that demo, like it didn't fit quite well in the test set. So I need to fix that. That's the first thing. But then the future plan is to introduce Bayesian quantile regression, right? So one really good thing with every single deep learning package, so it doesn't matter if it's TensorFlow or PyTorch, they have a accompanying Bayesian package. So TensorFlow has TensorFlow probability, PyTorch has Pyro. So all you do is you chuck it into Pyro, and you can say all the parameters have a Gaussian distribution. You can get a posterior distribution on that. So that's my immediate next step that I'm going to be doing. The second thing is I'm going to be extending time series. So right now it doesn't care about correlation between time series. So for example, if I'm selling phones, like the time series are going to be correlated, right? And that's going to be a fairly easy thing for me to add on to this thing. But again, like using the Bayesian method, that'll be easier. And that was it about the talk. So the takeaways, if you didn't follow the code, don't worry about it. That's not really what I was trying to sell. Try ProFeTorch. There will be some problems that it will perform better than Prophet. And the second thing that I really want to get at is that deep learning it can be more than just deeper learning, right? So in this case, there's zero hidden layer network, and it was all linear. And that was it. So any questions? Yeah. Thank you.
I think deep learning works really well for established phenomena or some physical phenomena, but Bayesian should work better for more nefarious domains, where
I think that's a orthogonal problem to what we talked about, but in general, no, I really think it depends, right? So Bayesian problems work for smaller data sets, and deep learning works for bigger data sets. That's a very general statement. Pyro was actually written in PyTorch, right? So it's a bit hard to just say this is good for this problem. No, that's not what I'm saying. No, because like I said, this was a small data set, right? So as soon as you have zero hidden layers, it's a linear layer, and I still wrote that in PyTorch, right? So look, you can actually write random forest in PyTorch if you really wanted to, right? So PyTorch at the end of the day is only just a gradient descent package, right? So and then you add the optimizers and everything else on top of that. So yeah. Okay. We'll talk later about this. This is like a whole another topic. Yeah, Tom.
This is a mathematician's question, and
yeah.
I'm thinking out loud rather than being very clear.
Yeah.
When you've decomposed your time series into Fourier components, but
yeah.
you're only using limited periods,
yeah.
and then there's the trend stuff and so on. What are you leaving out, and can you tell what you're leaving out in terms of information? And if it doesn't make sense, then...
No, that question makes sense. So, so do I know that what I'm leaving out? No, I don't, because this might be a really bad way of getting around this, is to have a large number of Fourier components for everything, right? So in fact, if I can get rid of all the monthly and the weekly ones altogether and just increase the number of yearly, because that'll just cover the basis, right?
Yeah.
And then to use a L1 penalty on the weights. So you can do that, and I'm not sure how effective that's going to be. Like, it really depends on how strongly.
Yeah, it wouldn't explain the time series as well,
No.
but it might be more precise.
Yeah.
It would
Yeah.
work.
Well, obviously, the more components that I have, like, the better it'll fit. But obviously, there's a risk of overfitting in that case. I don't really have a proper fixed answer for that question. So.
I didn't have a proper question.
Sure.
And we have time for one more proper question.
I've got one. So, Sachin, with the number of components in the yearly and monthly and weekly and daily
Yeah.
that you select, is there a way to optimize those parameters?
So that comes back to the same thing, right? So you can have an L1 penalty on the weights, or you can wait for the Bayesian version, which will automatically choose it for it, right? So, but yeah, for the short term, yes, that's the only way that I can think of right now.
Please join me in thanking SACHIN.
Hi, I'm Greg Perl from the Onset group. I head up the data science and analytic area there. I hope you enjoyed tonight's presentation. Always fantastic information that we get from that. The Onset group are the premium technical recruiters across, obviously, data science, machine learning, NLP, artificial intelligence. I'm here to help organisations build their analytics team and their analytics function with superior talent. There's lots of people out there, really good individuals across a range of different sectors that could be beneficial. And obviously I'm also here for the data science community to assist with understanding the market, understanding what jobs are out there, how to get into data science. So please feel free to reach out. So again, it's Greg Perl at the Onset Group, and I look forward to seeing you at the next meetup.